There are two approaches in hypothesis testing. One is using the critical value, which we studied before, and one is using the p-value or probability value, which we want to talk about now. First, we need to figure out what p-value is. What is p-value or the probability value? P-value is the probability of observing a test statistic value beyond or further away whatever we have observed from the null hypothesis, which is also called the realized significance level. P-value is the significance area beyond the statistic value we have observed. So let's go back to our two hypothesis testing that we have had, two-tailed hypothesis testing. In a two-tailed hypothesis testing, we have two tails and two critical values here, two rejection region, z of alpha over 2 here, negative z of alpha over 2 here. So two rejection, one is on the upper tail and the rejection region on the lower tail here. Suppose that we have our observed value of test statistics is z of x bar. So p-value is the probability of observing a test statistic beyond this value. Beyond means that it's either going to be on the right tail or on the left tail. So that's why we multiply the probability by 2 for finding the p-value. P-value would be 2 times the probability that the test statistics, the random variable z, would take a value beyond the current value that we have. The absolute value of z stat, which is the current value of the test statistic. Let's see an example. Let's go back and to our example 2, which we did the hypothesis testing for, a two-tailed hypothesis testing for. The p-value for that, let's compute that. So the test statistic value for example 2, the z stat was equal to 2.5. So the absolute value of 2.5 is also 2.5. So to find the p-value for that example, we need to find the 2 times the probability that z is greater than 2.5. The probability that 2 times the probability that z is greater than 2.5. You can use the knowledge that we learned from the probability chapter to compute this probability, either using the z table or using Excel. And if you do that, you have to multiply by 2, of course. The probability would be 0.0124 or almost 12,000, which is a low and a small value. So what is the intuition here? What does it mean, this value? What does it mean to be a high value or a low value, and what should we do with it? Well, the p-value means assuming that the null hypothesis is true, what is the probability that we get the observed value that we have now, or an observed value beyond this value, or a value beyond this value, or further away, either on the left tail or right tail, depending on whatever type of test that you have. So if the hypothesis, the null hypothesis is true, then the current observed value must be a likely event. We would have to expect to get this evidence. If the probability of getting this evidence is low, assuming the p-value is true, then this evidence, or the test statistic value, is an evidence against the factuality of, or the statement stated in the null hypothesis. It's a little confusing and difficult concept to grasp, so you need to repeat that and learn more about it so that it can stick into your head. So let's actually see a visualization of this. We have a two-tailed test here. As you see, we have the critical value on the right, so that's 1.96, and the critical value on the left, that's negative 1.96. And since we are talking about beyond the value, so we can talk about beyond 2.5. That means that any value here, So that's the probability of getting uh, a value for z greater than 2.5 or getting a value less than negative 2.5. So that's why we multiply this by 2. An easy approach to use and apply the p-value after you have computed the p-value is if the p-value is a small value, then you're going to reject the null hypothesis. How small it should be? Well, it should be less than the significance level. So we reject H naught if and only if the p-value is less than alpha, the significance level. So to help you memorize this algorithm, what should you do with a p-value? If the p-value is low, H naught then must go. So this little poem can actually help you to memorize what you should do with the p-value. How low or how small the p-value should be? It should be less than the significance level alpha. So if the p-value is low, H naught then must go. That means we're going to reject H naught. General scenarios for obtaining p-values. So we saw the scenario of a two-tailed test. Now let's take a look at one-tailed test. If we have, for example, a lower tail test, this is how the hypothesis would look like. The null hypothesis would state that the parameter mu, the average here, is greater than or equal to the mu 0. And the alternative hypothesis would say that no, mu, the parameter, is actually less than mu 0. So since we have here less than sign in the alternative hypothesis, we would have the rejection region on the left tail or lower tail here. And using the critical value approach, we would reject the null hypothesis if the value of test statistics is less than the critical value on the left. In this scenario, this is how the p-value would work. The p-value would be equal to the probability that z, the random variable z, is less than or equal to the observed value of test statistics z of stat. So the sign here, as you can see, is less than or equal to. So it's less than because we have a lower tail. And also that comes from the less than on the alternative hypothesis. Now let's see the case for the upper tail test. In upper tail test, as you can see here, the null hypothesis would state that the value of parameter mu here is less than or equal to mu 0, and the alternative would say no, the value is greater than. So since this is a greater than sign in the alternative hypothesis, this states that indicates that the rejection region is in the right tail or upper tail here, and we have only one critical value here. We are doing a z-test, so we're going to have a z alpha here. And following the critical value approach in hypothesis testing, we would reject the null hypothesis if the test statistic value that we observe is greater than the value of the critical value. So this greater sign that comes from the upper tail or right tail, which comes from the sign, the greater than sign in the alternative hypothesis. So following this, the p-value would be computed as follows. The p-value would be the probability that the random variable z, the standard normal distribution, is greater than or equal to the test statistic value. So this greater than sign again comes from the upper tail, which comes from the greater than sign in alternative hypothesis. And we already saw the case for a two-tailed test. In a two-tailed test, in our null hypothesis, we have equality sign, and in our alternative hypothesis, we have inequality sign, which indicates that we have two tail or two rejection region on the two sides of the tails or the distribution. And since we are dealing with a z-test here, our critical values of z of alpha over 2 on the right tail and negative z of alpha over 2 on the left tail. If you want to follow the critical value approach in hypothesis testing, this is how we would act. So we would reject the null hypothesis if the absolute value of test statistic is greater than z of alpha over 2. What does it mean? This means that if the observed value of test statistic is going to fall in the rejection region on the right, we're going to reject the null hypothesis. Also, if it falls on the left side or the negative side, the lower tail, we're going to also reject the null hypothesis. The p-value, as we learned before, for this scenario would be 2 times the probability that z is greater than or equal to the z stat value, the observed value that we have here. And as we learned generally, how we would act based on the value of p-value would be we would reject the null hypothesis if the p-value is low. And that generally means that if the p-value is smaller than the significance level alpha, we would reject the null hypothesis. So as the saying goes, when the p-value is low, h0 then must go, meaning that if the p-value is small, you're going to reject the null hypothesis. As I said earlier, the concept of p-value is a little bit tricky and maybe difficult to understand at first. So let's talk about the concept of p-value a little bit more. P-value answers the following questions. What is the probability, what is the likelihood of getting a test statistics equal to the observed value that we have on hand, or a value more extreme than that if the null hypothesis is true? So similar to a judging session, we assume that innocent until proven guilty. So we assume that the null hypothesis is true. Based on the assumption that the null hypothesis is true, the p-value is the probability that getting a test statistics that we observe or a more extreme one, if we assume that the null hypothesis is true. So for an upper tail test that you can see here, the p-value would be the probability that z is greater than the observed value, or that means equal to the observed value, a more extreme one, which is deeper in the rejection region on the right. Let's elaborate more on the concept of p-value. We have got an evidence on hand. That's the value of the observed value of test statistics. The opposition claim is that this is an evidence against the null hypothesis, meaning the observed value of the test statistics is a proof, is an evidence that H0 is not true. So what should we do? As a judge, we have the assumption that innocent until proven guilty. So we have to fight this claim. We have to verify this claim. If we can prove that the observed value or observing such a value, given that the null hypothesis is true, is very likely, it's not a surprise, then we have proven that the observed value is not an evidence against H0, but actually a consequence of H0 being true. So what we need to do is we have to prove that assuming H0 is true, it is very likely, or it is likely, to get a test statistic value equal to the observed value, or even a more extreme one. This is the concept of p-value. So this means that when something is likely, that means the probability of getting that test statistic, the probability of getting that evidence is high. Otherwise, if it is proven that the observing such a value, observing the current value of the test statistics, or a more extreme one, is unlikely, then that is going to be a surprise. That's going to be a shock. That's going to be an evidence against the null hypothesis. So the evidence would be against the null hypothesis, and we would have to reject the null hypothesis. So this means that if the probability of getting a test statistics equal to the observed value, for a more extreme one, is low, then that would make the observed value a shock, a surprise, an evidence against null hypothesis being true. So that means that we would have to reject the null hypothesis if it is unlikely that we would get the observed value of test statistics, or the probability of getting such a test statistic value is low. Similar notion, when the p-value is low, h0 then must go. That means it is very unlikely to get a test statistic value as equal to the what we have observed value when the null hypothesis is true. So we would have to reject the null hypothesis if the p-value is low. Interpretation of potential values for p-value. Generally, it is unwise to draw a firm conclusion, a firm border for the level of significance that we have in test here. But this is just for general understanding. This is going to be changed. You have to adopt it. You have to be actually wise, make your decision based on the problem and the background, the setting, the information that you have. But this is in general. For the values, for the p-value greater than 10% is generally non-significant evidence against H0. So if the p-value is greater than any value greater than 10%, it's not a significant evidence against H0. For values for p-value between 5% and 10%, it's marginally significant evidence. Again, it depends on the significance level of your experiment. For p-values between 1% and 5%, generally, it is considered as significance evidence against H0. But again, you have to interpret that based on your background of the problem that you're working on and the significance level that you're considering. And overall, p-values smaller than 1% are considered highly significant evidence against H0 and are considered to be a proof against H0 being true.